We're going to take a look at right triangle geometry. We're going to first identify right angle triangles. We're going to look at the Pythagorean theorem and its application, and then we're going to see how we can use Pythagorean triples. So a right triangle is one that has a right angle as one of its angles, which means a right angle is 90 degrees. So a right triangle has 90 degrees as one of its angles. Now, we have two main types of right triangles. The isosceles right triangle, which is one where the two sides are equal, and we have a scaling right triangle where all three sides are unequal. The Pythagorean theorem states that in a right angled triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides of the triangle. So look at this. We have side A, side B, and side C. From this triangle here, Pythagorean theorem tells us that C squared is going to be the sum of A squared and B squared. So let's apply Pythagorean theorem here. So we have, according to Pythagorean theorem, the hypotenuse, which is C here. So C squared is going to be the sum of 9 squared and 12 squared, which is 9 squared is 81, 12 squared is 144. So C squared is 225. So to get the value of C, we take the square root of both sides. So the square root of C squared should be equal to the square root of 225. Square root of C squared gets rid of the square, so it's going to be C. The square root of 225 is 15. Now we have this other example here. So according to Pythagorean theorem, remember the square of the hypotenuse is the same as the sum of the square of the other two sides. So 17 squared is equal to B squared plus 15 squared. 17 squared is 289 is equal to B squared plus 225. Let's subtract 225 from both sides. So 64 is equal to B squared. So to get the value of B, let's take a square root of 64, square root of B squared. So 8 is equal to B. So the missing side is 8 units. Let's look at this other example here. In this triangle ABC, Pythagorean theorem tells us that C squared is equal to 10 squared plus 24 squared. So C squared is going to be 100 plus 576. C squared is equal to 676. So we take the square root of both sides to get the value of C. So C is equal to 26. So we're going to look at Pythagorean triples. So a Pythagorean triple is a set of positive integers a, b, and c that fits the rule a squared plus b squared is equal to c squared. And so if I have a, b, c, what this is supposed to tell us that a squared plus b squared equal to c squared. So now in this example, we're trying to find the missing number. So we should have 9 squared plus 40 squared equal to x squared. So 81 plus 1600 or 1600 is going to be x squared. 1681 is equal to x squared, and so square root of 1681 is square root of x squared. So 41 equal to x. So if the set of numbers below represents a Pythagorean triple, what is the missing number? So we know that 12 squared plus x squared equal to 20 squared. So let's do something here. We're going to subtract 12 squared from both sides. Subtract 12 squared. So x squared is equal to 20 squared minus 12 squared. So let's apply the difference of two squares. Is going to be 20 plus 12, 20 minus 12, which is going to give us 32 times 8, which is 256. So x squared is 256. So we take a square root of both sides. Take a square root of x squared and 256. So x is equal to 16.